Welcome to the mini lesson for step number 15, hydrogen hydroxide. By the end of this mini lesson, you will be able to describe what a polar covalent bond is, as well as a hydrogen bond. You'll also be able to determine what some of the main properties of water are, such as how it expands as a solid, why it dissolves ionic compounds, surface tension, and its high specific heat. You'll also be able to tell why these properties of water exist due to the unique polar covalent bonds and the hydrogen bonds. So, what's so important about water? Why, of all the compounds out in the universe, are we focusing on water? Well, for one thing, it's essential to life on Earth. Uh, as far as we know, in order for life to exist, water has to be involved somehow. Humans are also made of water, mostly of water. So that's a good part of our body is made out of water. So it's a good reason to explore uh, some of the properties of water since we are made up primarily of water. Most of the surface of Earth is water. In fact, some people say that Earth is inappropriately titled. It should be called water since the majority of the surface is covered in water. Um, the unique chemical bonds and structures create unique properties in water, and that's these unique properties is what allows life to thrive. What allows water to be so essential in life in general. So that's why we will take a few minutes to understand the uniqueness of water. One property of water that helps give it its uniqueness is the fact that it has a polar covalent bond. If you remember in previous lessons, covalent bonds is the key word to covalent is co, like to cooperate. It means so to share electrons. So covalent bonds are sharing electrons. Polar covalent bonds also share electrons, but it's a little bit different. In covalent bonds, the electrons are shared equally between elements. However, in polar bonds, one side has more positive and the other side is slightly more negative. And the reason for that the oxygen atom is actually larger than the hydrogen atoms, and it has most of the electrons hidden within the atom. So therefore, it has electrons most of the time. This means that oxygen is going to be slightly negative, and also that the hydrogen atoms are going to be slightly more positive. What that's going to do is create a bit of almost like a pole, kind of like a magnet. If you kind of envision each water molecule as a mini magnet, that's in a sense of what's going on. In fact, that's where we kind of get our name polar bonds, is the fact that it's kind of like north and south pole as far as the difference of charges. So we have this side being more negative. That's the oxygen side, and then the hydrogen will be slightly more positive on that side. These polar covalent bonds uh, actually will create some really unique properties that we'll touch on a little bit later on. Another unique bond with water are the hydrogen bonds. The hydrogen bonds are, in a sense, real similar to the polar covalent bonds, but these are bonds actually in between individual molecules, whereas the polar covalent bonds are in between different atoms, such as the hydrogen atoms and the oxygen atoms. So hydrogen bonds are the bonds in between the actual molecules. What's Because of the polar covalent bond, where one side is slightly more negative and the other side is slightly more positive, so this means the positive charged hydrogen atoms are attracted to other negatively charged oxygen atoms. So these hydrogen bonds, which I'm going to put in red, as you can see, each negatively charged oxygen is going to be attracted and have a hydrogen bond to a positively charged hydrogen atom. So these are the bonds in between each water molecule, and which I'm putting in red. Now, the actual polar covalent bonds, those are a little differently. I'm going to put those in a different color. I'm going to use green to symbolize the polar covalent bonds. Those are in between the hydrogen and the oxygen molecules. So that the polar covalent bonds are what form the actual molecules. The hydrogen bonds are what actually link the individual water molecules together. So hopefully you can kind of see the difference between the two. Again, the polar covalent bonds are just to create the molecule of water, and the hydrogen bonds are what link all of the different water molecules together. Because of the hydrogen bonds, water actually expands when it becomes solid. Most of the time, liquids will actually become more dense whenever they freeze. Water is an exception, and the reason is because of the hydrogen bonds. What happens is when water is a liquid, they do have these hydrogen bonds, and they're able to move around a little bit more freely and take up any space in between. However, as it freezes, it's going to have less ability to move since it doesn't have as much energy. So when it does freeze, it will actually start making more solid hydrogen bonds with all the other water molecules. And when this happens, it creates unique geometric shapes. And these geometric shapes create a lot of space in the middle. And because of this, that's why the actual why water will actually expand when it freezes is because of all this extra space in here due to the hydrogen bonds. Another important property is the fact that water can dissolve ionic compounds, and this is due to its polar bonds. Water dissolves ionic compounds like sodium chloride, which we also know as table salt. And as we know with ionic compounds, um, what happens is, for instance, like with sodium chloride, sodium will give up one of its electrons to chloride, and chloride will take that electron in order to have that to fill in that valence of 8 electrons in its outer shell. When this happens, sodium is going to be slightly more positive, and chlorine is going to be slightly more negative. So what happens is whenever salt comes in contact with water, the negative end of water molecules are attracted to the positive end, or the positive charge of sodium, and then the positive end of water molecules is attracted to the negative atom of chlorine. And when this happens, it will tear the sodium and the chlorine molecules apart from each other and break that ionic bond. And when this happens, it will completely dissolve the sodium chloride into a mixture of sodium ions and chloride ions. To kind of help you understand this a little bit better, there's an animation I pulled from the internet, and we'll kind of talk our way through it. This is how water dissolves salt. What happens? We have our water molecule, and it has its polar covalent bond, and then you have your salt crystal on one side, and then the water, because of its polar charges, it's going to be like a little magnet, right? So what's going to happen is that the sodium ion has a positive charge, the chlorine ion has a negative charge. So these little magnets, basically the water molecules, are going to be attracted to either the chlorine or the sodium because of the charges, and they're going to start pulling apart the sodium away and the chlorine away from the actual block of salt. And these opposite charges of water, they're going to basically kind of engulf and separate the chlorine and from the sodium because of the polar covalent bonds. Another unique property of water is the fact that it has surface tension. And again, this is because of the special bonds that are created with water molecules. More specifically, it's due to the hydrogen bond. What happens is the water molecules towards the top are pulled down to create a type of surface tension. If you notice the water molecules towards the middle, they're going to be kind of separated or pulled apart from all directions. However, the ones on the top, there's not any water on top of them, so therefore they're going to be pulled towards the side or towards the bottom. This is going to create a bit of a tension, kind of like a rubber band, and it's going to allow basically kind of like a film in a sense, because of all this tension will be at the top of the surface of water. So lighter individuals like this bug will be able to actually stand on top of the water. If you notice, it's not in the water, it's literally standing on top of the water. That's the difference between buoyancy or floating, is that it's on top of the water. It hasn't actually penetrated the surface tension. Paper clips will also float on water, and but if you place it carefully to be on top of the water. However, if you just drop the paper clip in there, it would have enough force to break the surface tension and it would sink to the bottom. So that's a good clear indication of the difference between surface tension and buoyancy, is the fact that if you lay a paper clip on top of the water where it doesn't break the surface, it will actually stand on or lay on top of it because of the surface tension. However, as soon as you break that surface tension, it will plummet to the bottom. The last property of water that we're going to look at is the fact the water has a high specific heat. Um, and this, of course, is due to the hydrogen bond. So everything is linked to the special ability of the hydrogen bonds and the polar covalent bonds. But due to the hydrogen bonds, when heat is applied to water, much of the heat energy is used to break up the hydrogen bonds, which this leaves a lot less energy available to heat up the water. So that's why it takes such a long time to boil water. If you have a pot of water you're trying to boil to help for dinner or something, you'll notice it takes a long time to boil water because it requires so much energy to heat up. However, the reverse is also true. As water cools down, energy is used to reform these hydrogen bonds and between the water molecules, which means there's less energy is released as heat because all this energy is used to reform the hydrogen bonds. So since less energy is released as heat, the water cools down much slowly. This high specific heat of water has interesting effect on areas that are by the ocean, which is obviously a large body of water. Uh, During the day, the water is going to be slightly cooler than the land, since the land is able to heat up much more quickly. And because of the high specific heat, the water stays a little bit cooler. This is going to create a sea breeze onto the land during the day. And at night, the reverse is true. The land is going to cool down much more quickly than water because it takes a lot longer for water to cool down due to its high specific heat. And what this will create are land breezes because there's going to be a difference of temperature between the two. Okay, now that we have talked about hydrogen hydroxide, also known as water, let's kind of go over some of these some questions You might see some of these questions or something similar to it in your quiz for step number 15. So hopefully this will kind of help you start thinking in that general direction. Let's look at the first question. It says, which of these best explains why a paperclip can float on water? Now, before even looking at the possible answers, think about why a paperclip can float on water. Uh, it's, if we can remember, it's because of the surface tension, right? And the surface tension is created because of the pull from the hydrogen bonds in between the water molecules. So we're going to be looking for an answer that has to deal with. So A does not have anything to do with the hydrogen bonds. And C, B has something with hydrogen bonds in it. Let's read through it. Water molecules at the surface experience fewer hydrogen bonds than water molecules within the liquid. That is a true statement. We'll double check and see if there's anything else that has to do with hydrogen bonds, and no other question does, so B would be the correct answer. All right, question number 2. This states areas near oceans or large lakes tend to have more moderate climates than do areas far from large bodies of waters. Which of these statements best explains this observation? All right, so if we're looking at this particular question, they're talking about climates. And if we're thinking about climates, we're thinking of something that's going to affect the temperature. We're talking about moderate climate. So whatever the explanation is, it's going to have to deal with temperature. Well, if we remember back in our discussion about water, we were talking about specific heat, how it has a very high specific heat, and how that difference of how the fact that it can take a long time for it to heat up and take a long time for it to cool down creates things like land breezes and sea breezes. So let's look for something that has to deal with that unique property of specific heat. If we look through, only C has anything to do with high specific heat. So, and let's see, water has a very high specific heat, and that's exactly true. So C would be our correct answer. Question 3. Which of the following properties of water is due primarily to the uneven distribution of charge between the hydrogen and oxygen atoms? Now, this uneven distribution of charge between the hydrogen and oxygen atoms is also due to the fact that it's a polar covalent bond between the three different atoms, and this bond makes it, if you remember, gives it make it like a little magnet. And because of this, it's able to do some unique stuff. Let's look through and see if any of this has to do with the fact that it has a polar covalent bond. Its color is an indication of it. Its taste is not an indication of a polar covalent bond. Let's see, its ability to dissolve ionic substances. That is true because of the fact that one side has a slightly different charge than the other as far as a water molecule is concerned. It's able to rip apart the ionic bonds uh, of something such as like a salt uh, molecule. So C would be the correct answer. And let's look at our last question. Question number 4. It states, which of these statements about water is true? So let's just go through each one of them and see what we find out. A says its atoms share electrons equally. Bonds that share electrons equally are the covalent bonds, which water is to an extent, but it's actually a polar covalent bond. Polar covalent bonds do not share the electrons equally, and that's why it gives it its state of unequal attractions on the two sides of the water molecule. So A would be incorrect. B states it can dissolve all known substances. Well, actually, water can't dissolve everything. Anything you put in water won't just automatically dissolve. So we know that that's not true. It does dissolve ionic substances, ionic bonds. So, but not it does not dissolve all known substances. C says its molecules are further apart in the solid state than the liquid state. That statement is true. If we remember, because of the uniqueness of a hydrogen bond, it creates a unique geometric shape and creates more space in the middle. So that is true. Ice does indeed expand uh, when it comes into a solid state. But let's look at D. Just to double check, D says it has a lower specific heat than nearly all known metals. Uh, we know that water has a very high specific heat, so we know that this is not true. So therefore, C would be the only true and correct answer. The information within this mini lesson should help you prepare for step number 15 quiz over hydrogen hydroxide. However, I definitely do recommend to go over the online textbook as well as maybe look through some of the videos on Discovery Education website. Once you feel pretty confident about taking the quiz, feel free to do so. You're allowed 3 attempts on your own. But if you have any questions about hydrogen hydroxide or water, the properties of water, feel free to email, phone, text, or come by the live classroom on Tuesdays and Thursdays. Be happy to address any of your questions or concerns about step number 15 quiz.